Okay, so here's another scenario. So if you take a moment to look at what I've done, there is a label instruction up here. That is connected to an output, which is green all the time because, uh, well, this is always true. And I have a push button down here, and that's connected to a jump, right? So the question is, what's going to happen here? Well, think about the scan cycle. As we've talked about before, scans from top to left to right, right? So it goes here, then it goes to this next line, and then it actually goes through one more line, this end line, right? So what do you think will happen if I activate this? Let's take a look. So I've activated it, right? And it looks like nothing's happening. You would expect that we'd be caught in some sort of infinite loop, right? This would go down to here, and then we'd jump up, and it would never end. And our scan cycle would never end. And I can look in our status bit for our scan time, and it looks like our scan time is all normal. These things are all normal, right? That is because in PLCs, and unlike other computer programming languages, we cannot jump backwards. And this is the safety feature to keep us from going in infinite loops. There are ways to get into infinite loops in PLCs, and we might explore that later, but just know for the jump instruction, you cannot jump backwards. And this is why. You don't want to get caught in an infinite loop. Okay, let's look at another one. So this one's a very much more complicated looking implementation of these jump commands, but the idea is to show you kind of what these jump commands can do. So in this program, we're essentially just trying to get these outputs, which we're calling motors, to turn off and on every 3 seconds. So this will turn on for 3 seconds, and this one will turn off for 3 seconds. And they will switch between each other. And the way we're going to do that is with jump commands. We're going to use jump commands to basically skip entire boxes of code. So up here we have a latch. This latch is connected to these latches down here. Latching commands, you remember those, L and U. And while each of these is latched, they will jump to different sections. Okay, so let's follow this one. So this latch command will not be on when the program starts, so it's going to skip this line, right? It will then go to this line, and this line is always true. And this line says to jump to motor 1, to our label that is motor 1, called to motor 1. So this jump command is going to skip this line of code and this line of code and go straight to here, to here. So next, this is always activated with a XIO, and it's going to turn on this timer on delay for motor 1. And then next, it will go down to the next line of code, and it will jump to the end. We use a jump to end to skip anything else that we don't want to go over. Now in this case, it's actually unnecessary, because the end is actually right here. But that is good protocol if you're going to have a jump to end, to put it everywhere that it could go. Okay, so this will jump to here. It's going to jump right here. And so when the motor is done, when this motor hits done, it'll close this, reset this motor with the reset command, and latch this bit right here. And it'll latch this bit, and then it'll be done. Also, while that motor up here is timing, this timer bit will enable the output of the motor. Okay, so quick review. This will latch, and these will turn the motor on if it's on. So what's the next part? Well, this will be latched, right? Because we've turned on this latch down here. So we go back to the top, and we latch this. Now this line is enabled, and it will go to here, to this jump command. And where does this jump command take us? To motor 2. And so what does it do? it doesn't go to this next line, does it? Because we're jumping it. We're skipping it. We're jumping to the label called To-Motor-2. So we're skipping this jump command over here. And we're going to this one. And this one works in the exact same way. We have a done bit that stops when this one is done. And then it'll go to a jump to end. And what does the jump to end do? Well, we don't do this code. We don't do this stuff. We jump straight to the end. And the whole process completes over and over and over again until infinity. Let's try it out. Let's look at it. Alright, let's see what let's look at our functionality first. Okay, this is on. 3 seconds later, this is on. So as you can see, our motors are switching back and forth every 3 seconds. Like I said before, there's much easier ways to do this, but this is kind of an idea of what you can achieve with your jump commands. So let's take a look here. Okay, this is latched, so we're jumping to motor 2. I need to have a timer. Motor 2 is now running. 1, 2, 3. 1, 2, 3. Down here. Yeah. So this is a complicated idea of what the jump command can do. And essentially, jump commands are actually how computer languages like assembly work, which are low level, meaning closer to hardware programming languages. And that means you can do all kinds of crazy stuff with jump commands. If this crazy setup here confuses you a little bit, that's fine. You don't need to understand every single piece of it right now. The big takeaway here is, through jump commands, you can actually achieve some pretty crazy, interesting stuff.